Hello, I'm Steve Evans, and I lead Teneo's global team of technical customer success consultants. I know that's a lot of words, but our focus is simply to ensure our customers' technical needs are met, and they have a single person whom they can count on for all technical matters. That also provides us a great view into the challenges our customers face, so we can help others avoid the same issues. Hence, the creation of this presentation, which we hope will help many avoid some of the common pitfalls and have confidence when deploying Aruba Silver Peak SD-WAN technology into their network. Many I&O leaders, when investigating SD-WAN, have discovered it's like learning a new language. And just like learning a new language, learning the vocabulary first helps accelerate the learning of their team members and advancement of their SD-WAN project. That's why we've prepared this short webinar to explain 6 of the most important SD-WAN terms associated with the Aruba Silver Peak SD-WAN Edge platform, the technology that powers Teneo's co-managed and managed SD-WAN services. At the conclusion of the video, you should understand the main SD-WAN building blocks to help fast-track your SD-WAN and Secure Access Service Edge initiatives. Coming up, we'll discuss business intent overlays, application visibility and control, WAN optimization and why that's still relevant, forward error correction, and packet order correction. But first, we need to set the stage and talk a little bit about the first of the 6 terms, SASE. So why are we discussing SASE before delving into Aruba Silver Peak's SD-WAN need-to-know terms? Well, looking at the 5 core capabilities of SASE, it's not by accident that the leftmost orange pillar is SD-WAN. SASE is a cybersecurity concept that relies heavily on what legacy routed environments can't do, or at least can't do easily. A software-defined edge makes the transition to SASE much easier to achieve. Think of SD-WAN as policy-based routing, but based on business applications, wherever they reside. It's an important preliminary requirement for any company's SASE journey. Want to utilize any transport to any data center, branch, or cloud resource, including cloud security service? SD-WAN gives you the centralized management and control to make that happen for any of your applications. Want to roll out a new QoS policy for every location in a specific region, all at the same time? Again, this is easily achievable from the central management GUI of SD-WAN. First, let's discuss a brief history of SASE and why it's important. In August of 2019, Gartner first described SASE in the report, The Future of Network Security in the Cloud, and expanded upon the SASE concept in their 2021 strategic roadmap for SASE convergence. So let's define SASE. Secure Access Service Edge, or SASE, is an emerging cybersecurity concept. It's important to understand a bit of background on this new term, knowing that existing network approaches and technologies no longer provide the level of security and access control digital organizations need. Organizations today demand immediate, uninterrupted access for their users, no matter where they are. With an increase in remote users and software as a service applications, an increase in data moving from data centers to cloud services, and an increase in branch office traffic going to public cloud services rather than back to the data center, a need for a new approach for networking security has arisen. SASE is the convergence of wide area networking and network security services like client access security brokers or CASBs, firewall as a service, and zero trust into a single cloud-delivered service model. SASE capabilities are delivered as a service based upon several specific things. Number 1, identity, which can include people, groups of people, such as branch offices, devices, applications, services, and IoT systems. Number 2, the enterprise security and compliance policies of an enterprise and the continued assessment of risk and trust throughout any given session. All services must be delivered with a real-time context component. Gartner expects that by 2024, at least 40% of enterprises will have explicit strategies to adopt SASE, up from less than 1% at year-end of 2018. A SASE architecture identifies users and devices, applies policy-based security, and delivers secure access to the appropriate application or data. This approach allows organizations to apply secure access no matter where their users, applications, or devices are located. How can the SASE security model help your organization? Let's uncover a few ways. Number 1, increased performance. With a cloud infrastructure, you can easily connect to wherever resources are located. Access to apps, to the internet, and corporate data is available globally. Number 2, cost savings. Instead of buying and managing multiple point products, utilizing a single platform will dramatically reduce your costs and IT resources. Number 3, flexibility. With a cloud-based infrastructure, you can implement and deliver security services such as threat prevention, web filtering, sandboxing, DNS security, credential theft prevention, data loss prevention, and next-generation firewall policies. Number 4, reduced complexity. You can simplify your IT infrastructure by minimizing the number of security products your IT team has to manage, update, and maintain, all while consolidating your security stack into a cloud-based network security service model. Number 5, threat prevention. With full content inspection integrated into a SASE solution, you benefit from more security and visibility into your network. Number 6, data protection. Implementing data protection policies within a SASE framework helps prevent unauthorized access and abuse of sensitive data. And finally, number 7, zero trust. A zero trust approach to the cloud removes trust assumptions when users, devices, and applications connect. A SASE solution will provide complete session protection regardless of whether a user is on or off the corporate network. Now that I've laid the foundation with a brief description of SASE, let's talk about the Aruba Silver Peak SD-WAN terms that you need to know. So let's start by differentiating underlay and overlay, as this will be important to understand our next term, BIOS. An underlay network is different from the underlay that the IT industry has known for years. Or is it? The underlay network is the physical infrastructure above which the overlay network is built. It is the underlying network responsible for the delivery of packets across the network. Think of the underlay network as the physical transport infrastructure. It can consist of MPLS, Internet, LTE, or even low Earth orbit satellite. Underlays are the actual IPsec tunnels and physical paths taken. An overlay network is a virtual network that is built on top of the underlay network. Think of the underlay as providing a service to the overlay. Before we do a deeper dive on overlays and how they work in conjunction with BIOS, I need to define an Aruba Silver Peak key component, the orchestrator. Anything and everything you need to deploy, configure, manage, and troubleshoot is done from the orchestrator. It's the single pane of glass global management system, or GMS. Now that we understand a bit about overlays and underlays, let's jump right in with business intent overlays, or BIOS for short. The key here is business intent. The days of the application conforming to network constraints is over. In today's environment, when businesses must rapidly transition to a digital workplace, enterprises need the network to conform with the needs of the users, internal and external. BIOS help do just that. A business intent overlay, or BIO, specifies how traffic with specific characteristics is handled within the network. BIOS are used to create separate logical networks that are individually customized to your applications and requirements within your network. For example, shown here we have 3 business intent overlays. Keep in mind that these BIOS are configurable and you can have up to 7. I'm showing 3 here for simplicity's sake. We have a real-time overlay, an enterprise apps overlay, and a default overlay. Let's talk about how we can customize our overlay network using BIOS based on application characteristics. We'll use the real-time overlay to get a better understanding of the power of the BIO construct. The enterprise app overlay and default overlays will not be discussed specifically, but keep in mind the same concepts apply. Looking at the column headers at the top, left to right, we'll start with circuits. We have determined that 3 transports will be used to carry real-time traffic, but this is easily modified with a simple drag and drop from the orchestrator's GUI. Remember that the transports are the underlying physical circuits used to move data through the network. So the circuits used for real-time traffic include MPLS, Internet, and LTE as backup. Next, link bonding policy. How do I choose to utilize the transports, and how do I specify my service level agreements for this overlay? This is done through link bonding policies. Earlier, we talked about how the underlays are actual IPsec tunnels between devices and the physical paths taken. When there are multiple tunnels between 2 appliances, you need to specify the criteria for selecting the best route. This is managed by Packet-Based Dynamic Path Control, or DPC. More on DPC later. The question to ask is, how critical is this data? Choose the policy based on that answer. Working from top to bottom on the 3 policies, high availability is for the most critical data, and high efficiency for the least. Look at the link bonding policy we've selected for real-time traffic versus the link bonding policy we've selected for the default traffic. Voice traffic is critical and cannot accept delays or interruptions, so we've chosen the high availability link bonding policy. Silver Peak has unique technologies used to provide predictable performance over any link, including broadband. It is based on adaptive tunnel bonding with forward error correction and packet order correction. With a few simple clicks in the Unity orchestrator, you define the quality of the experience policy for applications. This includes the WAN path, QoS, SLA, and potential WAN optimization. Once defined, packets are distributed across the defined networks, tunnel bonding, with adaptive parity packets to correct for dropped or lost packets. Packets are reassembled, corrected for packet loss, and accelerated on egress without the need for retransmission. The next column is topology. Each logical network is independent from the others in terms of topology. You can choose either a mesh or a hub-spoke topology. Orchestrator builds the topology when you apply a business intent overlay to appliances. For example, for the real-time overlay, it's most appropriate to define a mesh topology between devices for video and voice traffic to minimize latency from additional hops. The SaaS, cloud, and internet apps column highlights the types of applications that would use this BIO policy. The Silver Peak SD-WAN solution takes an application-driven approach to more intelligently manage WAN resources to keep applications running even during brownout or blackouts. When different groups of applications are mapped to business intent overlays, the decision on which overlay to place the flow needs to be done correctly on the first packet. Otherwise, application performance will suffer. We'll talk more about internet policy and firewall and overlay defaults when we discuss application visibility and control, or AVC, later in the presentation. The key thing to know is that security and other configurations are easily managed in a BIO, meaning how traffic is treated is determined by our business intent. So, to wrap up an overview of BIOS, Orchestrator uses BIOS to dynamically build and maintain overlay networks, for example, which sites to build tunnels between and how networks should update the routing of the traffic when conditions change. Multiple BIOS can be created for different types of traffic. Which traffic matches a particular BIO is determined either by the label on the interface through which it enters the appliance or by matching traffic to an access list. The BIOS control things like WAN ports and network types for transmitting traffic, and what to do if the preferred link goes down or fails to meet specified performance thresholds. Business intent overlays allow you to specify preferred paths and link bonding policies based on application, VLAN, or subnet. Why is it important, and how does the concept of an overlay network facilitate a more application-centric secure infrastructure? Network traffic with different characteristics needs to be handled differently based on business needs. Overlays automate the creation of everything related to traffic flow, from QoS to link management to application routing. Let's discuss application visibility and control, or AVC. I previously talked about how in today's world, when businesses must rapidly transition to a digital workplace, enterprises need the network to conform to the needs of the users, internal and external. It's all about the users and the applications that the users need to be productive. Aruba Silver Peak provides robust capabilities for application visibility and control, or AVC, which allows for route policies to be easily established based on applications or domains. Think of this as application routing. Rapid classification is critical to make traffic forwarding decisions. Aruba Silver Peak has focused development on ensuring that they can classify a flow on the first packet. Some other SD-WAN vendors rely on third-party DPI inspection engines from companies like Quasmos, which often take a number of packets before determining the application, but not Aruba Silver Peak. The first packet IQ technology was built from the ground up by Aruba Silver Peak. We consider it a major differentiator. When different groups of applications are mapped to business intent overlays, the decision on which overlay to use for the flow needs to be done correctly on the first packet, otherwise application performance could suffer. Aruba Silver Peak's first packet IQ application visibility covers a wide spectrum of match criteria for traffic classification. Before we address each application visibility item, let's talk basics. What are we talking about here? I like to think of AVC as a map of the internet, a map of your company's workloads, the ultimate map to get your users to the applications, wherever they may be, quick, fast, and in a hurry. Here's a summary of what First Packet IQ provides. Built-in application groups with 200 plus applications and content-based categories. Built-in and automated updates to approximately 300 million internet domains. approximately 174,000 internet domains matched through IP intelligence, SaaS applications dynamically updated through cloud portals every day, approximately 7,000 built-in applications, out-of-band application definition updates, enhanced user-defined apps, defined applications on domain, IP address, or subnet, not just port and protocol, and finally, scalable ACL infrastructure based on string match. Let's sum it up and associate the BIOS with the ABC. Aruba Silver Peak's Unity SD-WAN solution builds virtual network overlays that can be mapped to business intent policies. Each business intent overlay is provisioned with its own access policy, virtual topology, underlying transport mechanism, and QoS policies. Simply put, you configure the BIO to send the user traffic to the destination resource based on the first packet, over the link you specify, with QoS you configure, all from the same orchestrator GUI interface. And don't forget the DPI database is updated from the cloud portal every day with Aruba Silver Peak's first packet IQ technology. Aruba Silver Peak's WAN optimization technology is called Boost, but let's set the table a bit before we jump into that. We've already discussed two of the three major components that make up Aruba Silver Peak's SD-WAN solution, the orchestrator and the cloud portal. The third component to be discussed are the appliances. They're called Edge Connect, or EC for short. As a quick recap on the orchestrator and cloud portal, the Aruba Silver Peak orchestrator enables you to globally monitor performance and manage Silver Peak appliances, the ECs. This is the global platform used to configure the BIOS that we've already discussed. Using the orchestrator, you configure business intent with a click of a mouse. The orchestrator pushes the policy to the SD-WAN Edge Connect appliances. Long gone are the days of having to connect to multiple devices one at a time to troubleshoot or to make changes. I like to think of the orchestrator as the component that makes up the management plane and the control plane. The router-like ECs can be considered the primary data plane component. Incidentally, the separation of the management, control, and data planes is well refined in the Aruba Silver Peak SD-WAN solution. Said another way, if the orchestrator goes down, which is not likely, the SD-WAN appliances continue to process traffic. Let's not forget, the orchestrator helps provide unprecedented levels of visibility into both legacy and cloud applications with the unique ability to centrally assign policies based on business intent to secure and control all WAN traffic. Policy automation speeds and simplifies the deployment of multiple branch offices and enables consistent policies across applications. Next, the cloud portal. In a nutshell, the cloud portal is a key component that you never really need to think about. It's managed 100% by Aruba Silver Peak, and as a customer, you have zero access to it. The cloud portal manages all licenses, and here's the good part, it downloads cloud intelligence to the Aruba Silver Peak EC appliances via the orchestrator. Why is that the good part? Remember, when we discussed application visibility and control, or AVC, and the first packet IQ, they're more than just buzzwords. These are components that provide unprecedented visibility and control of the application wherever they live and makes user requests happen quickly. And yes, workloads, if not already in the cloud, soon will be. It's cloud intelligence. Cloud intelligence is the unique feature of Unity Edge Connect. Aruba Silver Peak's Cloud Intelligence delivers real-time updates on the best performing path to reach hundreds of software-as-a-service applications, ensuring users connect to their applications in the fastest, most intelligent way available. And finally, the SD-WAN appliance itself, Edge Connect, or EC. Aruba Silver Peak Edge Connect appliances ship in various form factors that cover hybrid WAN needs of small, medium, and large deployments. With the help of an Aruba Silver Peak partner like Teneo, we help you size the EC appliances based on the overarching requirements of the branch, DC, or cloud deployments. Of course, you can deploy virtual Edge Connects as well. Think about this concept. When you deploy a virtual EC in the cloud, you're really extending your SD-WAN overlay fabric to the cloud. You manage it just like you would a physical appliance. Said another way, these appliances can be deployed with dedicated hardware or as a virtual network function, or VNF, running over all the market-leading hypervisors on commercial off-the-shelf x86 hardware. It's important to note that while licensed as a separate feature, Unity Boost integrates with SD-WAN in the same software image or same VNF. On to Boost. Aruba Silver Peak WAN Optimization, called Boost, is an optional WAN optimization performance pack that combines WAN optimization technologies with Edge Connect to create a single unified WAN edge platform. Boost allows companies to accelerate performance of latency-sensitive applications and minimize transmission of repetitive data across the WAN in a single unified SD-WAN edge platform. Is WAN optimization dead? It depends on who you ask, so let's talk about it. Forget the speed of light for a second, but let's be real. For global networks, WAN op will be around for a long time. For example, in some areas of China, standard internet can sometimes experience massive data loss, as high as 40% due to oversubscribed circuits. Teneo has overcome this issue for customers with sites in China by utilizing the Aruba Silver Peak Regions feature in conjunction with Boost. Today, in the era of SD-WAN, the role of WAN optimization still makes a huge difference in overall network performance. Improved application performance and throughput are both key to delivering better experience to users and customers. Some people would say, as bandwidth constraints decrease and become highly available at a cheaper price, technologies like data deduplication or compression to balance lower capacity links is no longer the most sought out goal. Similarly, other WAN optimization techniques like TCP optimization of proxies and application-specific proxies are also becoming less applicable. Cloud-ready networks of the modern era have not only reduced latency, but have also decreased the need for these once required WAN optimization techniques. In all things network engineering, the real answer is, it depends. Let's further our discussion on the Aruba Silver Peak Boost WAN optimization solution. It rocks. Aruba Silver Peak takes SD-WAN performance even further for latency-sensitive applications or applications where large amounts of data must be transferred across the WAN. With the optional Unity Boost software performance pack, EdgeConnect integrates Silver Peak's field-proven WAN optimization features in a single SD-WAN solution. By having Boost integrated with SD-WAN, it can be provisioned after the initial SD-WAN rollout for a given end customer without having to service chain an additional VNF for the sole purpose of WAN optimization. Boost is enabled at the business intent overlay level, enabling Boost on critical applications while not requiring it for less sensitive applications. The Aruba Silver Peak Boost feature includes two key components. Application acceleration. This improves the application's response time over distance. Think of this as the latency mitigation. This is TCP acceleration in Silver Peak lingo and includes techniques such as selective acknowledgements, window scaling, and message segment size adjustments to mitigate poor performance on high latency links. And data reduction. This eliminates the transmission of redundant data. This is the capability also referred to as network memory in Silver Peak terms. Remember this when you talk to other SD-WAN providers that boast about their WAN optimization. Chances are the other guys might call it WAN op, but it's most likely just TCP acceleration alone and doesn't include the data reduction component. A few final words on Boost. It's optional, and you don't have to have it in order to take advantage of the other Aruba Silver Peak features. If you do want it, you can allocate it where and when you need it with just a click of a mouse from the orchestrator. Why would that be important? Let's use an example. Your enterprise requires end-of-the-month DR backups between sites. Allocate Boost to the individual BIOS associated with the backup application, and any traffic that matches the BIO will be boosted. Traffic that doesn't match the BIO will transition to the next ordered BIO. When the backup is complete, reallocate Boost as you see fit. Wow, dynamic WAN op. One final challenge that Aruba Silver Peak and SD-WAN can address is how to best use higher bandwidth internet connections that are as little as 1/10 of the cost of private line services. Internet and wireless links often suffer from packet loss and jitter and are more likely to experience outages. Silver Peak's forward error correction, or FEC, reconstructs lost packets, which avoids TCP retransmissions, substantially increasing the effective performance of broadband links. The ratio of FEC packets to data packets is configurable depending upon the business criticality and real-time requirements of the application. Packet order correction algorithms reorder packets that arrive out of order at their destination. Tunnel bonding provides several benefits, including optimizing the SD-WAN for availability, throughput, and efficiency. Bonded tunnels may be configured from 2 or more physical WAN links to form a single logical overlay connection. As an example, bonded tunnels can be configured with 2 MPLS connections to create a primary bonded tunnel. One MPLS connection might be serviced by AT&T and the other by Verizon. In another scenario, a single tunnel or logical connection can be configured with an MPLS link and an internet link, even if the speeds of these services are not the same. Depending upon application requirements that are mapped into a virtual WAN overlay policy or business intent overlay, EdgeConnect can load share traffic across both physical links or can map data traffic to one and forward error correction packets to the other. If one link were to fail, the remaining link would continue to carry all the traffic, including FEC packets, to keep the connection active and the application alive, avoiding any interruption or data loss. We have just covered the 6 most important SD-WAN terms to know when implementing Aruba Silver Peak SD-WAN. You should be well equipped as you move forward on your SD-WAN journey. If you're still not rock solid on any of them, I recommend rewatching that portion of this video, or give us a call and we'll be glad to talk through it in more detail with you, especially how it applies to your network and desired business outcomes. To learn more about Teneo and how we help companies have confidence in deploying new and innovative technologies, please contact me or check out our website. We look forward to meeting with you.